So number one, we're going to write a nuclear equation for the alpha decay of Pa, which is proactinium. So the first step is we're just going to take this symbol given, and we're just going to rewrite it. Okay. So 231, 91, Pa. So you're just rewriting it. Okay. Really quick before we get started, I just want to kind of review what these numbers are. Does anyone remember what that top left number is?
Mass.
Okay, this is your mass number. And then does anyone remember what the bottom left number is? Good, atomic number. Okay. All right, so we're looking at decay, which means the atom's always going to break down. So you're always going to have an arrow right after it. Okay, so this atom is unstable. It's going to break down. This time, it's alpha decay. Okay, so I'm telling you it's alpha decay, which means it's going to give off an alpha particle. So go ahead and look in your notes for what that alpha particle looks like. The top number should be 4. The bottom number is 2. Okay. And when I write it, I prefer the alpha symbol. If you wrote yours as 4, 2 in helium, like I have above, is that okay also? Yeah, that's fine. Either or is fine. Okay, and then we're going to fill in the blank. So what other element does proactinium change into? Okay. The name of the game is balancing. Okay. If you have a mass of 231 on the left side, what does your mass have to be on the right side? It has to be 231. Okay, we can't just have mass disappear. So the easiest way to do it is just take 231 minus 4. Okay. So what is that? Okay, 227. Okay. Then we're going to subtract our bottom numbers. What's 91 minus 2? 89. Okay, and then which one of those numbers identifies the element? The top or the bottom? The bottom. Okay, the bottom number identifies the element. So find 89 on the periodic table. And they all have goofy names, so you can just give me the 2-letter symbol.
AC.
Good. AC. Okay. Okay, so again, while we're getting used to this, go ahead and check your work. So here's the arrow. So the right side of the arrow has to equal the left. So your mass numbers, does 227 plus 4 equal 231? Yes, okay, they have to be balanced. 89 plus 2, does that equal 91? Okay, so when we're looking at our numbers, just we're balancing the left versus the right side. Okay, any questions on the first one? Okay, for number 2, we're going to write a nuclear equation for the beta decay of francium. Francium. So again, you're just going to rewrite the symbol given. So I'm just rewriting 223, 87, and then FR. All right, and then since it's decaying, I'm just going to have the arrow. It's going to break down. Okay. And this time it's beta decay. So what kind of a particle is it going to give off? Beta particle. Okay. So you're going to look in your notes for what that beta particle looked like. It was the 0, -1. And I like the B for beta, but if you put an E for electron, is it the same thing? Same thing. Okay, and then again, we're going to fill in the blank. So what element does this break down into? And it's the same story. So the right side of the arrow has to equal the left side. Okay. So 223 minus 0 is still 223. Okay. Then we have 87 minus -1. What is that? Plus 1. So what's 87 plus 1? 88. And then if you look at 88 on the periodic table, what's the symbol? RA. Good. And the -1 can kind of throw people off because a minus -1 is plus 1. Okay. We can still check though. 88 minus 1, does that equal 87? Yeah, good. Again, 223 plus 0, does that still equal 223? Good. So for 3, we're writing a nuclear equation for the alpha decay of samarium. So what are you going to start with? Good. Okay, rewrite that particle, right? So 14962 SM. Okay, then what are you going to write? Hold, before you get that far, what has to come next? Okay, just the arrow. Decay means it's going to break down. Okay. All right, so then if it's alpha decay, what kind of particle are you going to write? 4,2. Good. 4,2, the little alpha, or helium. Okay. All right, then what's 149 minus 4? Good. 145. What's 62 minus 2? Okay. And then which number between those two are you using to identify the element? Okay, 60. So if you find 60 on the periodic table, what is it? ND. Okay, ND. Good. Okay, so try number 4 on your own. Okay, so the beta decay of promethium. And then we'll check answers in just about a minute. Okay, so number 4, it's beta decay, so what kind of particle is going to get, like, shot out? Okay, so write your beta particle. So then 165 minus 0 is? Okay, and what about 61 minus negative 1? 62, and what element has an atomic number of 62? Oh, SM. I wrote a P. Okay. Give me a thumbs up if you got it right the first time all on your own. A thumbs in the middle, I got it wrong, but I understand why. And then thumbs down is like, I got it wrong and I just don't know. Okay, good. Okay, look at number 5. Write the nuclear equation for alpha decay. Again, try this one on your own and then we'll check it in about a minute. Okay, for number 5, what are you starting with? What's your top number? Good. MD. And it's alpha decay, so what kind of particle does it shoot out? Okay, so the 4,2. I'm going to write HE this time. Is it the same thing? Yes. Good. Okay, what's your top number for your next product? Okay, 245. What's your bottom number? 99. And then what element has the symbol 99? ES.